Hello everyone, welcome to the experiment 3 for the principles of general chemistry, separation of dyes in candies by paper chromatography. Firstly, I will briefly introduce some basic background. You may wonder what the chromatography is. The chromatography is a physical method for the separation and identification of a specific chemical component in a mixture. In this experiment, we will separate and identify the dyes that are used to produce colors for the shell of chocolate candies by using paper chromatography. The separation is based on the different distributions of the components between the stationary phase and the mobile phase. The stationary phase is a solid that has large surface areas, where the chemicals can be absorbed, and for the mobile phase, it is solvent, which is forced to flow over the stationary phase. In this experiment, the more soluble components will be transported faster. In contrast, the components that are strongly absorbed by the stationary phase will be transported slower. These differences in traveling speed will allow the components in the mixture to be separated. In paper chromatography, a small spot of the mixture to be separated is applied onto paper, which serves as the stationary phase. The solvent is allowed to flow up the paper through the spot by capillary action. The compounds separated can be described by their retention factor, or the RF value. In this formula, di is the distance traveled by a specific compound, and ds is the distance traveled by the solvent. Here we go, let's start our experiment. As you can see in the picture, the chemicals and devices we used in this experiment are very simple. In the first step, you need to place chocolate candies with different colors in 6 cavities. Then, add 3 drops of 1% sodium chloride solution into each cavity. Wait for about 3 minutes until the dyes are dissolved into the solution. If necessary, you can use a commercial hair dryer to evaporate some water to concentrate the solution. Then, you need to draw a straight line with a pencil from the short edge of the chromatography paper. Please do not use a color pen or ball pen. Along the line, mark 6 spots that are separated from each other by about 1 centimeter. In the next step, you need to apply a few drops of the color extract onto a pencil mark with a capillary tube until the color is visible. To minimize the spot size, you need to make sure they are applied exactly in the same position. Label the color of the spot using a pencil, repeating this step on different pencil marks for each color extract using a clean capillary tube. After all extract have been applied, fold the opposite end of the strip over a glass rod and hold it in place with paper clips, and the length of the strip should be adjusted to fit into the beaker. And next step, fill the beaker with 50 ml 1% sodium chloride solution to a depth of about 1 centimeter. Put the glass rod with a strip across the top of the beaker. Ensure that the end of the strip rests in the solution but does not touch the base of the beaker, and the solution is below the level of the spots. Cover the beaker with aluminum foil. The solvent will gradually rise by capillary action, carrying the components in the spots along. When the solvent film has reached about 1 cm below the folded part of the strip, carefully remove the glass rod. Immediately mark the solvent film with a pencil, and then dry the paper strip with a hair dryer. Please identify the colors of the component dyes for each spot. Circle the position of the most intense part of the separated color. Measure the distances from the original positions of the spots to the solvent front and to the center of color components for each Candies. Repeat step 2 to step 7 using deionized water as the mobile phase. In this experiment, 2 mobile phases have been adopted. They are sodium chloride solution and water. The result of using 1% sodium chloride solution is on the left, and the result of using water is on the right. You can simply compare these results by yourself. The RF values of each component can be calculated by the equation mentioned above. The table shows the calculated RF values. According to these RF values, some conclusions can be drawn. For example, compared with water, the sodium chloride solution showed a better separation. In addition, the DI value of blue number 2 dye is 0, indicating that it has the strongest interaction with the chromatography paper. That's all for the experiment 3. Thank you for your attention. If you have any questions, please feel free to contact us. Bye bye!